Hello, everyone. My name is Grigorik. I'm a PhD student at the University of Texas at Austin under supervision of Professor Miloš Grigorik. And today I will talk about the PyKokkos project itself and the most recent changes that we've done to make it as usable as possible. So let's begin with quite motivation and intro for PyKokkos itself. When the Kokkos is a high-performance, neat, powerful framework that allows you to write high-performance applications on C++, a lot of developers struggles with one part, which is the C++ itself. And the C++ is a brilliant language, but developers can stumble upon some issues with a compilation, with some cryptic messages, especially if they using some templates, and the building process and dependency process is not very neat. So that's why a lot of people in academy uses Python as a main language for high-performance computing and quick prototyping some applications. And since we had this gap in the past, we had to fill it in some way sooner or later, and we developed a PyKokkos to fill the gap from the C++ Kokkos to the Python. So this is a quick example of PyKokkos and how the things look when you develop the applications like this. And it's not really so hard. So as any high-performance framework, the PyKokkos allows you to write something like kernels. If you are familiar with CUDA, you are familiar with this term as well. And since the PyKokkos is high-performance EDSL, embedded domain-specific language, that means that we support all of the Python, but we just add some part to this Python side to allow you to write this Kokkos-like kernels. And this kernel definition is just a simple Python function that have decorator pk.workunit, which will be in the future translated into the C++ compiled, and we will see in the future how this works under the hood. We also allow some restricted things that you can do in this kernel itself. Since this is domain-specific language, you cannot call any third-party library in this kernel that will be translated, because we cannot translate everything from Python to C++. And of course, we need some data that we would be able to manipulate with. So we allow to construct an arrays that would be performance and portable. You would be able to modify it both from the host and from the device. And eventually, you would be able to invoke these kernels, pass some data structures, and use some device-type operations. So under the hood, it works like this. Don't be scared. It's very easy. You will take all of the Python files, check all of them using analyzers and AST visitors. And if this Python file have some decorator pk.workunit, we will translate it from Python to C++ and serialize to C++ code. And eventually, we would be able to compile this to DLL libraries and invoke these DLL libraries using the neat module pybind and pass all of the things in the world that we want to pass in this pybind module. And since we are targeting Python, the logical question is, what about performance? Will we have some overheads? And in this chart, you can see that we implemented XMiniMD framework. We not implemented that. We translated from C++ to PyKokkos. And all of the charts show that we don't have much overhead from comparing to Kokkos itself. So since this part is clear, now we can think, what about some improvement? Since we just went from the lower level language as a C++ to high level language as a Python, we can implement some optimization and algorithmic things to this using this Python wrapper. And one of them is a kernel fusion. So eventually, when the programmers write some high-performance application, sooner or later, they divide each block to the logical block as we know it as a kernel, as a class. And when we have a lot of these kernels, we will spend some time to actually invoke them, to retrieve the data from them, and load the data into the device. All of these things make some overhead when we make some mega kernel with one gigantic kernel as our main kernel. We will have less overheads in offloading and invocation. And in a Python side, we would be able to actually not harm any performance, but improve it by doing things on the high-level language. So in this figure on top of that, you can see that we actually will not call any kernel when we have invocation function, but we will just remember that we will call this kernel, and we will pass some data into this kernel. When we actually access data that's associated with some kernel, then we have to actually invoke something. And during this invocation chain, we can figure out that we can actually merge two kernels into one. And even this merge can be more optimized by merging for loops, for example, inside of these kernels. So, for example, we invoke these two kernels, add and multiply, and in two of these kernels we have for loop. We would be able to merge these two for loops into one for loop, and our performance will just have some speed ups. And on the figure, from this figure, you also can see that we have compared the unfused and fused applications with a dashed line as a baseline, and we have pretty much speed up for each application. So this was about the PyKokkos and how it works, but what's so wrong with it, and how we actually need to change it to make it usable? So next couple of slides will be something like interactive way to decide what we want to remove as a developer, as a Python developer from this Python-like code. Again, this is EDSL, Embedded Domain Specific Language. So it is not a Python. This is actually something that will be translated. So first thing that we notice as a Python developer that we hate, a lot of Python developers for some reason hate this thing as a typing. All of the things in your function require type. So first things first, let's just get rid of the typing and annotation. Next thing is some unnecessary abstractions. In the past, we had 3 ways to define exactly the same thing that will produce exactly the same output and that will produce the same results. Why do we need these 3 ways? Because we forked from Kokkos. We wanted to be as Kokkos as possible. Now we are trying to rethink this, because now the developer needs 3 times to learn how to write something. No, we don't want to do that, and we want to do the things as simple as possible. So instead of functors and workloads and work units, we decided to stick with the most neat implementation, which is work unit. And as you can see, it is something like CUDA function with a decorator, pk.workUnit. Next thing is kind of important, and my PhD advisor mentioned that 9 months ago, that we eventually will delete this from the projects, and why do we need to wait for something? Let's just remove it. pk.views. Views is the same thing as in Kokkos itself. So if the developer wants to prototype something in a Python, he needs to understand how the things works in PyKokkos and how the things work in a lower level in a Kokkos itself. Why do we need to do that when we have already existing abstractions like QPy, NumPy, and tensors. So now we support all of them. And instead of implementing things by invoking our internal APIs, we just will translate everything to our internal. It is under the hood. No one will see that. And third part is also related to the Kokkos and to the fact that we, in the beginning of our way, we try to hack something. We tried to just borrow some instruction from Kokkos. So we had to write 3 lines just to define a scratch size. It might be correct, but why do we need this when we can use Pythonic way? And that's where the Python decorator arguments came into place. So this way, we would be able to define scratch size and for each specific function, and it will be much easier to read this code, modify, and understand as non-code writer. So eventually, we came up from something like this to neat abstraction like this. So we kind of fixed the Pythonic side. Another example from the same framework, XMiniMD, is this square sum function. Before this implementation, we had to write this gigantic code. We had to do some duplicated instructions. And why do we need to do that workload? Why do we need to do this abstract classes when we can write and describe it just in 4 lines? Same thing for arrays and for kernel invocation. Instead of invoking some class and hoping that it will do something under the hood, we will invoke everything explicitly. So another important part that I encountered with when I came to this project was the installation. I think that was one of the hardest things that I done in this project, because I spent something like 2 weeks just to fix our CIs. And let's see why this was so bad. So to install our initial PyKokkos, we had to first install our previous version of PyKokkos, which was PyKokkos base. It was proof of concept. It was not bad. It was just something that we had to deal with. So clone PyKokkos base, make conda environment, install dependencies. Now need PyKokkos base build. And at this step, we had 3 ways how we can build the project. What do we need? 3 ways? Who knows? So next, install this build version. Again, 2 ways. Clone our main repository and build our main project. Actually, there is like step 8, test that everything works, but we are talking about building now. And the more steps you have, the more chances that you will done something wrong at each one of them. And in this case, we just had dependency hell with a step 4. When we tried to update some library, when we tried to update the Kokkos, because the PyKokkos depends on Kokkos, we had like a bunch of errors, a bunch of compilation issues. And of course, these 3 ways how we can deal with the same thing to achieve the same result is not very neat as well. So how we solve this? First thing is we had to remove any C++ from the user perspective. We treat user as a Python developer. We don't need to deal with a C++ as a Python developer. Why we need to deal with a C++ as a PyKokkos developer? And remove the unnecessary dependencies. Embedding all of the dependencies in our build script was one of the first steps we had done. So eventually, of course, we removed this PyKokkos base repository that we had as a proof of concept. Also, one of the biggest milestones was the conda integration. So by integrating everything with something like environment manager, by doing this, we allowed to not dealing with any dependencies at all, and just specifying all of them in one file. And our greatest thing, I guess, is a Docker, and greatest thing that you actually will have in any installation process. So currently, we still have to invoke 4 instructions to build. 4 is like less than 7, but our end goal will be just pip install PyKokkos. But for now, you're also able to do this with Docker container, which support CUDA and OpenMP on any device. So the next section will be related to our future work and something like our roadmap that we plan to achieve in the next couple of months. So as I mentioned one slide before, we still have to deal with some installation instruction. We don't want to do this, so we eventually want to come up with some conda forge or official conda channel installation or PyPy installation channels as well. So one thing about PyKokkos and the problems that we have now is compilation process, because for now it is the slowest process that we can have, because each time when we need to recompile the function, recompile anything that's invoking, for example, none of the Kokkos functions actually, or like one Kokkos function, we have to build against all Kokkos. We have to include everything in our final C++ file. So this is currently a bottleneck. How we want to solve this, the best idea is to have something like smart includes. So include things smartly instead of including everything. That's very logical, but it's much more complicated than you think. And another idea that still looks like a hack is forward declaration files or forward files. And as you can see from this table, we require something like 5 seconds just to recompile things. So this can be done very easily, optimized very easily as well. And our future direction, it might be unobvious, since we came up from C++ to Python. Now we want to support C++. It's like, where's the logic? And the thing is that we received some comments about the fact that we would like to have some functionality to invoke Python code from the C++, because a lot of developers still have C++ code. They don't want to rewrite everything to the Python to have the same speedups, but it would be really neat to have something like a function to invoke PyKokkos function from the C++ side. And we have something like this workflow that we would like to achieve. Basically, we would be able to call a Python from C++, and from this Python side, we would be able to modify any data. We would be able to invoke PyKokkos kernels, and essentially, we would love to return this data back to the C++, so the C++ developer will do anything that they want to do with it. So to sum up, I just want to recap that the PyKokkos is a high-performance framework that allows you to write high-performance code, high-performance portable code, and achieve the same performance as a Kokkos. And I would love to remind everyone that PyKokkos now is under the active development stage, which means that we will address any issues, any comments that you will put into our Slack channel or into our GitHub. And of course, I would love to say thanks for all of these people, because without them, the PyKokkos would not be like alive. Thank you.
Yeah, time for a question.
So I had a question when you were defining your array data with like a NumPy array. How does that work with, like, if you're using CUDA? Like, is this actually a NumPy array, or are you sort of interpreting it as like something else?
Yes. So one thing that we had to think about is when we are defining NumPy array, we cannot like handle it to CUDA application. So in this case, this is a responsibility of developer to write a QPy array. When you use CUDA space, you actually need to use CUDA arrays.
Okay, thank you.
So regarding the packaging, I think indeed Kokkos does not have official conda package for the moment. And how do you maintain the conda package for Kokkos itself?
For Kokkos?
Because you have dependency to Kokkos.
Oh, yes, right? Yes. By dependencies, I meant the CUDA dependency, the dependency from the third-party libraries. Since we are able to just clone the Kokkos using CMake files, we don't need to use conda in this case. So we will do these things dynamically.
First of all, great talk. How well does this interop with other Python ecosystem libraries? Like you mentioned NumPy, but there are other, high-performance array APIs and things like pandas, and how does it fit into the rest of the ecosystem?
Yeah, for now we are trying to support as much high-performance libraries as possible. For now we support, I guess, only 3 of them: NumPy, QPy, and Tensors. But that allows us to support host, CUDA, and SAMD. So for now, it's not a big problem for us, but we would love to support all of that.
Do you want to ask your question or take it off? So
I've always been curious. I understand that there's C++ error are, they're difficult to deal with, but how bad does it get when you write Python code that's wrong and that your translation layer fails? How manageable? Did you get some feedback from external people?
Yes. So we got some feedback recently, actually. This was one of the things that we fixed. We are trying to fix constantly, and we still have some PyKokkos developers that provide us feedback about the cryptic error messages, because sometimes they will throw up the C++ output. So our first argument is negligible. And we are trying to handle all of these exceptions. And we are trying to specify the exact same Python location. So the developer would not need to know about C++ at all.
Yeah, because there is a risk it's going to be even worse, right? So
yeah.
C++ is going to be you trying to Python.
Yes. So, for example, one of the most frequent issues is with an unmanageable memory when we are trying to pass NumPy array to CUDA application. So we are trying to deal with a lower level as well.
Okay. Yeah, thank you very much.